Most divers eventually learn about helium as a diving gas. Helium reduces narcosis and decreases gas density. For decades, helium has been the gold standard for deep diving. But what happens when helium itself becomes the problem? What happens when you want to dive so deep that even helium starts to cause neurological problems? At those extreme depths, some divers and researchers have started experimenting with a gas that sounds completely absurd: hydrogen. Hydrogen is the same gas that powered the Hindenburg, the most flammable gas in the universe. It's a gas that most divers wouldn't even consider breathing. And yet, hydrogen may be one of the most promising gases ever investigated for ultra deep diving. Today, we'll examine the science behind using hydrogen as a deep diving gas and how certain divers, including Dr. Simon Mitchell and his Wetmules team, have already started using it for deep exploration dives. This program is completely self-funded, but if you want to support Scuba Science or the Dive Saga channel in general, you can do that by subscribing to the channel, leaving a comment, liking the video, and you can even join the channel. By doing so, you support us in a structural way and you get access to extra content, such as member-only videos, the Dive Saga soundtrack, and the Scuba Science scripts, in case you want to study a little bit after watching the video. To understand why hydrogen diving needs to exist in the first place, we need to look a little bit at what came before it, at helium, why helium is used, and specifically why it can't be used beyond certain depths. In our previous video in the Scuba Science series, we discussed why divers use helium. It's a non-narcotic gas and it has a very low gas density, making breathing a lot easier at greater depths. This makes it an ideal gas for deep diving, but it also has one problem. At extreme depths, mostly beyond 150 to 180 meters, high pressure nervous syndrome becomes a problem. HPNS was first discovered during very deep commercial diving operations, and some of the symptoms include tremors, muscle twitching, impaired coordination, and neurological dysfunction. Unlike nitrogen narcosis, which is caused by breathing a gas under pressure, HPNS seems to be caused by the pressure itself, combined with a helium-rich environment. That being said though, for most technical divers, HPNS is somewhat irrelevant as it only occurs at great depths beyond 150–180 meters, where most recreational technical divers would never venture. But for those few divers that are attempting world-class depths, HPNS becomes a real problem. For decades, the standard solution was simple: add some nitrogen back into the breathing gas to cause a mild form of narcosis that can subdue the tremors. And this is one reason why Trimix became so popular, the mixture of helium, oxygen, and nitrogen. But unfortunately, nitrogen does cause that problem of narcosis, and while it can subdue the tremors, it does cause impaired judgment. The deeper the dive becomes, the more nitrogen is required to suppress the HPNS, but also the more narcotic the gas becomes. And at the same time, don't forget that nitrogen is more dense and therefore increases the gas density at depth. So divers face a trade-off. More nitrogen means less HPNS, but also more narcosis and more difficulty breathing. So researchers have begun asking, is there perhaps another gas in the universe that has all the benefits of nitrogen, but none of its disadvantages? Hydrogen has several remarkable properties. First of all, it is the lightest gas in the universe, followed by helium, which is the second lightest gas. Hydrogen is approximately half the molecular weight of helium. And this means that hydrogen produces an incredibly low density breathing gas, which is exactly what we want at depth. Remember that gas density is one of the major obstacles in deep diving because it increases breathing resistance, and this work of breathing can also cause the diver to become fatigued and to even develop carbon dioxide buildup, so something we do not want. Hydrogen creates the lowest density breathing gas ever used by divers. Second, hydrogen appears to have mild narcotic properties. I know this sounds like a disadvantage, but remember that inducing a little bit of narcosis to subdue the tremors caused by HPNS are actually something that we want. So the hydrogen does subdue the high pressure nervous syndrome by introducing a tiny bit of narcosis without the density that nitrogen adds. The most famous hydrogen experiments have been conducted by COMEX, a French commercial diving company. Throughout the 1980s and 1990s, COMEX conducted several experiments using hydrogen as a breathing gas. They pushed diving deeper than ever before in an attempt to support offshore oil and gas rig operations. And at the depths that they were operating, helium-based gases were already producing serious HPNS symptoms, so an alternative was needed. And this is where researchers started experimenting with gas mixes that included hydrogen, such as Hydrox and Hydreliox. Hydrox being hydrogen and oxygen, Hydreliox being hydrogen, helium and oxygen. The results were remarkable. COMEX successfully conducted several experimental dives to depths of over 500 meters or 1500 feet using Hydreliox. Some experiments even went as far as simulating dives in hyperbaric chambers to over 700 meters or 2100 feet. At these depths, the hydrogen helped reduce the HPNS symptoms while keeping the gas breathable by reducing the gas density. However, researchers also discovered some disadvantages because even at these depths, hydrogen did produce narcotic effects beyond what was desirable. Just as nitrogen eventually becomes narcotic, so does hydrogen given enough pressure. The difference is, of course, that hydrogen only becomes narcotic at far greater depths than nitrogen does. But isn't hydrogen explosive? That is the first question that everybody always asks, and the answer is certainly yes. Hydrogen is highly flammable, and when hydrogen and oxygen are mixed in the right, or let's say wrong proportions, you absolutely get a highly explosive mixture. And that does sound somewhat incompatible with life support systems. But of course, when diving at great depths, so little oxygen is required because the partial pressure is so high that as long as we stay below 5 or 4% oxygen, the mixture is somewhat stable. Even so, hydrogen handling does require very specific protocols. This is also one of the reasons that diving with hydrogen has, for now at least, largely remained in the realm of research and highly exploratory niche diving operations. So yes, hydrogen is flammable, especially when combined with oxygen, but because of the great depth, so little oxygen is required that the mix does not become super unstable. For decades, hydrogen diving was mostly a highly commercial diving experiment. But then a cave diving team decided to revisit it. In 2023, a team called the Wetmules wanted to dive the Pearse Resurgence in New Zealand. This team included Richard Harris, Craig Challen and Professor Simon Mitchell. And they conducted what is widely believed to be the first rebreather-based deep dive that uses hydrogen as some of the gas strategy. The Pearse Resurgence in New Zealand is famous for its extreme depth, so they needed solutions beyond just helium. A previous dive in the system had reached 245 meters of depth, but had produced significant high-pressure nervous syndrome in one of the divers. And so, to investigate whether hydrogen could offer a solution, they inserted hydrogen as a breathing gas at the deepest part of the dive. The The diver actually breathed a Hydreliox mixture, hydrogen, helium and oxygen, between approximately 200 and 230 meters, so beyond 600 feet. The results were somewhat encouraging because the diver reported that no HPNS symptoms were present and that there were also no other obvious physiological side effects from breathing this hydrogen-based gas. But it is important to note that this is one singular experiment, so it's not a huge data set to draw conclusions from. But it does demonstrate, in a sense, that hydrogen may offer a solution for those deeper dives where a helium-based mix is no longer the best choice. So you may ask, if hydrogen is lighter than helium, if it's less narcotic than nitrogen, why aren't we using it more on deeper dives? And there are several reasons. The first one being that most divers simply don't actually need it. Most recreational technical dives occur well above 120 meters, 400 feet or so. At these depths, HPNS is simply not an issue. The gas density of helium is still very manageable, and the mild narcosis that is induced by the nitrogen is also very manageable. On top of that, hydrogen, as mentioned earlier, requires highly specialized handling because of its explosive nature. And thirdly, the scientific data set remains very small. Yes, people have successfully used hydrogen in the past, but just because somebody can do something without problems doesn't mean that that is scalable. Because researchers do still have questions about the long-term decompression behavior of hydrogen as a gas. Not to mention its thermal effects or simply the handling safety issues. So again, hydrogen really only becomes an attractive option where helium stops being a good option, and those depths are simply beyond what most divers will ever venture to. Hydrogen is simply not likely to replace helium anytime soon. Helium really does still remain the ideal solution for the overwhelming amount of technical dives. However, hydrogen may become a bit more of a staple for those extreme deep dives where helium no longer does the job. In many ways, hydrogen does solve two of the most pressing issues of ultra-deep diving, being the high-pressure nervous syndrome and the gas density issue. For those exploration teams that have to push past 250 meters, hydrogen can absolutely become a bottom breathing gas in the future. In conclusion, hydrogen is not a replacement for helium. It's not a recreational diving gas, and even in the realm of technical diving, it's really only practical for extremely deep dives. From a scientific perspective, hydrogen is definitely fascinating and promising. It's the lightest gas in the universe, it has an extremely low gas density which helps with the ease of breathing, and it is way less narcotic than nitrogen. So lots of advantages, but it is also an explosive gas, especially in a mixture that contains more than very low percentages of oxygen. Nevertheless, it is fascinating to think that we keep discovering new ways of sustaining life at extreme depths. That's just one of the ways that researchers and dive teams like the Wetmules keep further pushing scuba science. Guys, I hope you liked this episode. Thank you so much for watching. Remember to subscribe and join the channel if you can. I will see you next time. If you're into scuba diving, make sure to also follow the Dive Saga Dive Debrief podcast. You can find it on Spotify and YouTube. In this podcast, we cover the behind the scenes of our Dive Saga episodes.